Hi everybody, so in this video I'm going to go over everything that you need to know for part 1 of your final exam. Alright, so here we have the first quiz that we did, order of operations. So as you know, order of operations, pandas, parentheses, exponents, multiplication, division, addition, and then subtraction. Alright, but just remember that even though multiplication and division multiplication seems to come first, it's actually multiplication or division depending on what's first from left to right. And for addition and subtraction, same thing. It's whatever comes first from left to right. So here we have an expression. And so there's no parentheses, there's no exponents, but there is multiplication. So you go ahead and do that first. 7 times 4, 28. 3 times 3 gives you 9. And when you add them up, you get 37. Alright, so here is a problem with a subtraction and an addition. So in this case, as I said before, you do whichever one comes first. It's not addition then subtraction, it is whichever one comes first from left to right. So first we do 7 minus 4 and we get 3, and we add 3 and we get 6. Alright, so here we have x is equal to 12 and we have an expression that we have to take the x value and substitute it into that expression. So we now have 12 minus 5 times 2 all squared. Alright, so what we want to do is first parentheses, but within the parentheses we have to make sure we're going in the right order. So within the parentheses we have to first multiply, we get 10, now we can subtract and we get 2. And once we have that, now we can raise it to the power of 2 to get 4. Alright, so here we have a little bit of a trap. So you're being asked to find p squared, and of course you would take the negative 3 and substitute it in for p. But if you take your calculator and do negative 3 squared, what you're going to end up seeing is a negative 9. However, you're squaring the entire negative 3. So when you square any negative number, you always get a positive number. So negative 3 squared is actually 9, not negative 9. And that was our first quiz. Alright, so now the second quiz goes on to do some word problems, and so this is slightly more challenging. And when you learned how to use algebra to solve word problems initially, you only knew how to work with one variable. So that's what we're going to do right now. So here we have Daniel. His weight is 1.5 as much as Susan, and please ignore this, there's no anita in the problem. So his weight is 1.5 as much as Susan, and together they weigh 250 pounds. So it's super important to list the unknowns and the knowns because you'll be using those later to set up your equation. So we know that Daniel weighs 1.5 times as much as Susan, and we also know that the sum of their weights is 250. Alright, but what we don't know Susan's weight and we don't know Daniel's weight. Now the way the question is phrased, it says that Daniel weighs 1.5 times as much as Susan. So they're talking really about Susan more than they are about Daniel. So it's easier to use the variable for Susan's age. Susan's weight. This should be weight. Alright, so Susan's weight, we'll call it S, and Daniel weighs 1.5 times as much, so we can call Daniel's weight 1.5 S. So now, let's look at the fact that we're looking here at what we know. We know that the sum of their ages is their weight, the sum of their weights is 250. So that means that 1.5, which is Daniel's weight, 1.5 S, which is Daniel's weight, plus S, which is Susan's weight, will give us 250. Now all we have to do is solve. So 1.5 S plus 1S gives us 2.5 S, and that gives us 250. So when we solve, we get that Susan's weight is 100 pounds. Now, when we're being asked to check, well, we know that Susan's weight is 100 pounds. We also know that Daniel's weight is 1.5 times that, so Daniel's weight would be 150 pounds. When you put it together, you do in fact get 250 pounds, so we know then that we did the question correctly. Alright, so here we have another word problem. It's slightly harder because now there are 3 people involved. We have Tony, who has twice as much money as Alicia, and we also have Ralph, who has, Alicia has 16 less than Ralph. And together, all 3 of them have $200. Now, again, we list the knowns and unknowns. We know that Tony has twice as much as Alicia. We know that Alicia has 16 less than Ralph. And we know the sum is 200. Now, we don't know Tony's money, we don't know Alicia's money, and we don't know Ralph's money either. That's missing from here. All right, so I would use Alicia as our variable, and the reason for this is because everyone is being compared to her. Tony's being compared to her, and so is Ralph, and well, clearly she's herself, so she's being compared to herself. All right, so Alicia will be represented by A. So since Tony has twice as much money as Alicia, Tony has 2A. Well, since Alicia is herself, she has A. And since Ralph, well, let's read the sentence again. It says Alicia has 16 less than Ralph. Well, since Alicia has 16 less than Ralph, that would mean that Ralph has 16 more than Alicia. So Ralph actually has A plus 16. Now, we also know that the sum is 200. So when you take Tony's money, Alicia's money, and Ralph's money, and you add them all up, you should get 200. So that's what I did over here. 2A plus A plus A plus 16. So Tony, Alicia, and Ralph gives you 200. So we can simplify that and solve. And when we simplify and solve, we get that A is equal to 46. So that's how much money Alicia has. Now going back to the original problem, remember that Tony has twice as much as Alicia, and Ralph has 16 more than Alicia. So I just multiplied Alicia's money by 2 to get Tony's, and I added 16 to Alicia's money to get Ralph. And so now that's how much money each of them has. So of course you always want to go back and check to see if your answer makes sense. So we add 92 plus 46 plus 62, and it does in fact equal 200, which means that what we did makes sense. All right, so let's keep going. All right, so I know a lot of people were not a fan of these, but it's also very important to know the properties of addition and multiplication. All right, so for the first property, for the first question here, we have 9, and we have its opposite, which is negative 9. So when you add a number to its opposite, you will always get 0. So like, for example, 2 plus negative 2, 5 plus negative 5, you'll always get 0. And so the name of this is the property of opposites of a sum. When you add the opposites, you always have a sum of 0. So that's why that is I. All right, so if I take, moving on to the next one, if I take an expression and say it's equal to another expression, oh no, pausing for a second. Okay, so if I take an expression and it's equal to, all right, there's going to have to be a part 2. I'll be back.